So basically, if you are using a web nowadays, you are using GraphQL. And this standard has many implementations on the server and client sides for basically any platform in existence. And it was so popular that a few days ago, actually, GraphQL became its own foundation. So there is a GraphQL foundation hosted by the Linux Foundation. Governs the direction on how the standard will be propagated over and over. So the GraphQL is the query language, because QL means query language, exactly. So while most of us probably know at least SQL query language. So why GraphQL? How GraphQL differs from SQL? First of all, GraphQL has object-tree syntax. So we are actually describing the queries in form that is quite similar in form to JSON, which actually speeds up the adoption. And at this point, I would probably show you how the GraphQL query looks like, but it doesn't look like that. And you'll like it. Okay, so why I think it's a great thing? Because if we can describe our query in terms of object-tree graph, because it's a tree, and every tree is in graph, so object graph tree. And why does it matter? Because we no longer need ORMs there. At least I haven't heard about anyone trying to write down the ORM for GraphQL, because it doesn't have any sense. We are not mapping relational data to objects. We already are using objects. So another thing that GraphQL exposes nicely, and I can show you here, are fragments. Because, for example, in SQL, ANSI SQL from 1998, I think, there was a problem that when you have some, repeated kind of values in your queries that are repeated in several places, you have to actually, copy-paste them over your query. After that time, it has changed. We have with syntax that nobody uses, that was glued on top of it. And in GraphQL, this was something that was thought about upfront. Another thing that the GraphQL exposes is the type system, because just like SQL has core type system and extensions over it for every different implementation on the SQL database, and the same is for GraphQL. There is a common type system that is used by every server-side implementation and client-side as well, that allows us to statically type our APIs. And this is a great advantage over the REST, because in REST we have, of course, Swagger, for example. But the problem here is that Swagger, it can be outdated. It's a layer on top. And I've seen a ton of endpoints that have never used REST and Swagger in the same place. Okay. This was a nice question from Stack Overflow. Which HTTP response code do you use for your host when the resource you want to add already exists? You don't need to answer, because there are like dozens of them. And to be honest, more than half has sense actually to, 910 conflict already exists, and so on, because there are status codes that could be used in this context as well. There are some solutions like OData and things on top of it, and that will make REST working. But also the problem is that they are additions; they are not rules, no strict rules. Also, for example, OData doesn't solve the problem of overfetching; it can only solve the problem of underfetching. And they are also exposing this problem that since you can include basically everything. And you can also accidentally expose more than you would like, because those things are made for you. And in GraphQL, all of the schema you are describing is explicit. So yeah, before I should start GraphQL, this is what I would call the best description of REST. It's not a set of strict rules. It's not a standard. They are just guidelines, and you can comply to them or not. And this is, for me, a big part of the problem here. And yeah, and GraphQL is actually a standard, and it has specification written in pages. I read it all because I'm actually an original author of the F# server-side implementation for GraphQL. Do you know F#? Oh, wow. Okay. Yeah, those are companies using it, not all of them, only a few of them. And yeah, this is how the query looks like, and also the result aside. The result is actually an object tree. We have JSON here, because most of the existing implementation use JSON, but this is not, it's not something that you have to do. Specification itself uses object tree, so if you want to have client and server talking in message path, you can use message path. Also, the GraphQL doesn't tell you to use HTTP itself. In my company, when we started to, inventing that thing back in 2016, we were talking about using GraphQL endpoints over 0MQ, for example. And yeah, for those are so-called fragments, which describe reusable pieces of data that you can embed in your query. This is the inline form. And also, fields can be parameterized. So those are not methods, not in the nomenclature used by GraphQL. Those are called parameterized fields. So no methods. Also, GraphQL doesn't use CRUD, so we don't have create, update, delete. And I forgot how this one here. One thing here. We have only queries and mutations. Queries which work on read-only queries, mutations which work as requests altering the state of our application. This is quite similar to what CQRS offers. And how do they differ? Mostly since we are able to execute queries and don't think a lot about the state of the application. All we actually need to do is to execute the query itself using any way possible. For example, we can parallelize all of the field resolution along with our query, while in mutations we have to process them sequentially because the state of the current mutation could be dependent on the alteration of the state from the previous one. Subscriptions are, I don't know if they are still experimental, I think not. But they are allowing us to make, publish subscribe pattern over the GraphQL because queries and mutations were usually, but not quite, request response, and I hope to talk about it in a minute. So yeah, GraphQL also has an introspection API. So basically, it allows us to expose its own type system over the GraphQL server itself. And why this is great? This is great because we are having tooling for that. Basically, when you want to create a tool for GraphQL to, for example, create a documentation explorer or any kind of actually, I don't know, exposing your type system, type checker, and things like that, all you need to do is to have an endpoint for your GraphQL server. Everything else can be, inferred from that point. Single URI, no problems. And this should be in normal conditions. I've prepared the demo, but hopefully GraphQL also is exposed as an endpoint on the client side. What do we have on the client side? We have a multitude of libraries, mostly in JavaScript, because GraphQL was created by Facebook for Facebook needs originally. It was its reference implementation was made in JavaScript to make make it more familiar with eventual adopters. And because Facebook has its own implementation wrote in PHP on HVM, because this is their thing they are using on the server. But reference implementation is written in JavaScript, and there are, I would say, two major libraries that are exposing those capabilities on the client side. They are serving things like caching and HTTP requests and so on. For example, when you are using those, you usually don't have to explicitly say, now make HTTP request, fetch some data. You basically say, this is the shape of the data I need, and this is where I'm going to insert them in my view model, basically. So you don't need to tell when or how this fetching should happen. It's a responsibility of the libraries to tell you about it. And there are two major ones, I would say. Relay, which has been created by Facebook. It's basically something that can sit on top of React. It's very fast, because Facebook needs, but it also creates an additional set of constraints on your GraphQL schema in order to comply to it, because it exposes things like nodes, edges, because we are talking about graph connections between your objects, and the connections themselves. And for that, another company produced another library, both for client and server, which is very popular. It's called Apollo. And it can sit on top of existing technology stacks, so things like Redux and Angular, for example, because so far, if you want to use Relay, you will basically constrain to React. And this is how example client-side in Apollo looks like. So on top, we have basically a fragment of GraphQL query that is requested by the component below. And it also describes information about data that's used there, and so on and so on. And basically everything that we have up top on the top can be directly mapped into the fields below. So it's pretty straightforward. You see you have no fetching over there, or no explicit caching. This is handled by the library itself. And yeah, since this should be a single sequential talk, we should all be hyped by now and talk about some downsides of this. So let's go to them quite fast because we don't have a lot of time. One problem is about query optimization, because GraphQL is very dynamic. You basically, as a client, you are describing what data do you need, and as a producer of that data, as an endpoint API developer, you basically have no idea what your consumers might ask about. So this is kind of a problem, especially when it comes to problem of n+1 selects. Like here, for example, on the left we have query. On the right side we have a part. It's not a full. It's a part of the server implementation written in JavaScript. So we have those functions called resolvers, and what they basically do, they are extensibility endpoints for us as developers. So we say that for this field in this object, this is the resolver function that, given the object, will resolve this field, or this method will execute it using the function that you have provided. And here is the example when we have, for example, we want to fetch first 20 customers, and later on it turned out that we also want to get the orders for them. But the problem is that we haven't prefetched those orders, because from this perspective, we didn't know that the client might need orders for the customer further down the line. So we basically make one query for the database to pick up those 20 customers, and later on for every single one of them we then make another query to get orders for them, for each of those customers. So this is why it's called n+1 select problem, where n is those first 20 customers. So before I will talk about, because there are two different ways to resolve this problem, and I will talk about both of them. And to understand the first one, I would first need to introduce you to how we did it in F#, because all of those solutions are particular to the implementations themselves. So in F#, we basically have three phases. First one is called schema computations, when you are describing your domain logic using this library we have provided to you. And when you are starting your server, you basically are initializing your schema, initializing your server, GraphQL server actually. And later on, when the client is sending you his or her query, he is basically sending you two things. One is the query, GraphQL query itself, it's a single string, and a JSON map for variables, because this thing I haven't told you about. We have variables in GraphQL queries. So, for example, you can use, if you are repeating the same query over and over with a single value change, like in this first 20, we would like to take, skip, for example, first 20 and take the next 20 ones. We would like to have this made in the repeatable fashion using, for example, the variables which we can pass along with the query itself. And we split those two in action. First query is, basically it's parsed into abstract syntax tree, and then the information about these fields that client wants to take is combined with the information about the resolvers, the return types, and so on on the server side, because client doesn't have exact information about implementation detail on the server side. And we combine those two together, and in the result we have a single execution unit. This is called execution plan. We know exactly which fields those our client wants and how to retrieve them at this point. All we don't know yet are the variables. And once we pass the variables, we can evaluate, the entire query. And why is it so important? Because, for example, when the same person uses the same query over and over again, we don't need to actually evaluate this query from the scratch every single time. We could, for example, cache the execution plan somewhere in the register and reuse it later on. And this will have several implications later. What else could we do? So, right now, because of the limitations of F# and .NET itself, the schema compilation, it's actually not done at the compile time, it's done at the runtime when you are first initializing your schema. It's a singleton in your application. And for example, a few days ago, there have been announced a Go implementation, making Go language, which is basically creating that schema at the compile time using Go code generator. So this is something that is generating all of those information-specific optimization for your schema at compile time instead of runtime. I think that the same could be done in C#, for example, using Roslyn code generators, and in future in F# once the type providers over type will work. And why is it important for us? Because it will drastically cut the time of the initialization for your schema, and therefore it makes it a more valid option to use statically compiled languages for example, serverless. Because those optimizations only depend, they are only useful in statically typed languages. In dynamically typed ones, like for example JavaScript, you don't have all of those information about type system anyway, so you are relying on the JIT and runtime optimizations every single time. And another, which I already mentioned about, is this idea of execution plan, which we can cache in the registers, reuse later on, and potentially, for example, if this query is used often, quite often, we could spend a little bit more time and compile it ahead of time into a single function that is as fast as the REST endpoint that you as a developer would write. But here, everything is generic, so you don't need to write the same field resolution logic twice in two different endpoints. You only do it once. And I think that this is a great idea for the future. And this is also related to our problem with N+1 selects. Because one of the solutions is simply to expose full information about what clients requested for us at the level of every single resolver. Because in this case, we could simply basically tell, I know what field am I supposed to fetch, but I also know what other fields could be fetched next, further down the line during the execution of subsequent fields. So if I know that I'm supposed to, for example, fetch only customers from the database, but I see inside this execution plan that somewhere down the line I will also need the orders, then I can include that logic that will prefetch that data on the resolver level. But this has also some limitations because you're not always able to map explicitly GraphQL query to actually your database queries. This is quite complicated because this will strictly bound our domain logic to our data model. And another solution for that is called, there are actually a set of libraries. They are usually called data loaders, like data loader.js, or Haskell, which is written originally in Haskell in Facebook also. And what they allow you to do is to basically create some kind of a cache, which you can ask, you can actually create inside a logic that will batch all of the requests that you will send to that cache. It will batch them and return you a promise that will be executed once all of those queries will be, awaited, basically. So what we see here is that we are creating the data loader, which instead of fetching one orders for one customer, it is fetching all orders for all customers where their customer ID is one of the specified in the batch. Later on, we can take our customers, like those first 20, and for each of the customers, we execute the load operation using that customer ID. What you have in the result is the promise, not actual value, but the promise that somewhere in the future the value will come, but we will not tell you exactly when. And when actually the underlying implementation will start to await for that value, then this method, this function will be executed to fetch all of the requests we gathered so far in the single call. So we changed n plus 1 selects to basically 1 plus 1 selects. One for every level of nesting in our GraphQL query. This is still not perfect because we still are not executing all of the. We still don't prefetch all of the data at once in a single call. Instead, we are using one call per each nesting level. Another problem is related to BigQueries because they are introducing two problems. One is that since we can expose all of our domain logic in a single query, what will prevent our users to actually try to take all of the data we have in our database in one single query? And another one, when, for example, our clients are using mobile devices and need to prefetch quite a big chunk of data, they need to write a quite big query and pass it along the way. So this is another problem. Solution for the first one is something called query complexity analysis, and it's implemented also by, I think, the most production-ready GraphQL implementations on the server side. So what it actually allows you to do is to add something like weight for each field. So how costly it is to fetch that field for you. And later on, before executing the actual query, we can make some kind of an aggregation and compute the weight for the whole query itself. And for example, this is a GitHub example when you are using the GraphQL endpoint. You can basically read what limitations does your query need to comply to in order to be executed successfully, because otherwise you will just be denied. And for the second part, if we don't want to pass all of the data all at once, some of the implementations, like ours in 2016, was I think the first one, was basically computing a hash for your query and returning it to you as document ID along with the response. So later on, from your client side, when you would like, for example, to use the same query again, you don't need to pass the whole GraphQL query itself. You can just use the document ID. and execute it with different set of variables, for example. And this is also why execution plan was such a great idea here. Also, from what I know, Apollo server, which is a server-side JavaScript implementation, also offers something like that. It's called Hash, if I'm right, but it's in the something like beta of Apollo, I think. And another problem is related to huge replies, because since we can, basically put all of the data, take all of the data from the server in one go, we can wait quite a while until it comes up to us. So the problem here is that what we will do on our client side while waiting for the query. We sometimes would like to be able, for example, to tell this data is more important than this one. For example, we want to fetch the list of the user posts first and take the comments for those posts later on when they will be ready. But we want to present those posts as soon as possible. And this is an experimental directive. It's not official yet, but it's also implemented, for example, in F# and in Apollo, which is called defer. Here. Basically, it allows us to mark the fields as less important ones. So when we are getting the result, first we don't have those fields fetched, but later on in subsequent replies from the server, we have those data up there, and it's fetched automatically for us, so we don't have to do it by ourselves. The path is describing the path inside the response, object tree, to insert this data to. And the limitation is that, of course, those comments need to be nullable in the first place, because GraphQL query also describes fields as nullable or non-nullable in the type system. So, no null reference exceptions anymore. And how much time do we have? Okay.
A couple of minutes.
So, just to finish, I think that from the designer perspective, the greatest achievement of GraphQL is the ability to describe your domain as one single object graph. Because, when we are exposing our domain using REST endpoints, we basically are working in the following manner. We are giving pieces of puzzle for our users and tell them, this is a piece of puzzle from my domain. You figure it out how to, make the whole image out of it. And this is something I consider bad, and something that is great in GraphQL, because we can expose our whole domain in one single interconnected graph of relationships. And the more relationships we describe, the better we describe our domain, the better we will, the better endpoint we will get. Because in REST, you will have to pay an extra cost for fetching every data that is more than the minimum needed for your client. But here, since the client can exactly tell and is supposed to exactly tell you what data does he or she needs, then we never basically pay the extra cost related to the relationships that are not used anymore. And this is extra because this is a question I got quite often. Why use GraphQL? Why not just use your data? And initially I wanted to create it as a bullet point list, but it turns out that there are nuances in making the decision that are not easily described as short sentences in bullet points. So instead of that, I decided to use something I would consider perfect use case for both of them. And for OData, for me, this perfect use case is a rich grid view, for example, for some internal business B2B applications. Like we have a table where every field can be queried and every field can be filtered, sorted, and we probably need some kind of aggregation over that, and of course paging. Because GraphQL is useless for you in that if this is your case. Because for example, GraphQL doesn't describe anything like paging. Why? Because you can page in using many more than one pattern, like take skip first 10 and take next 10. this is not the only way. Actually, neither Facebook nor Twitter use their paging like that. They are using cursor-based paging. So every single entity you are fetching has its cursor ID, and when you are taking the next page of data, you are saying basically something like that. Take the next 10 elements after the element marked with this cursor ID. Sorry. So this was not the case for them, and initially Relay.js didn't even offer the option to page your queries using I would say traditional method, so skip take. It was not possible even in the first version of that library. And yeah, so OData, perfect for data aggregation. It can be embedded as part of your REST HTTP endpoint. That's it. So what is the perfect use case for GraphQL? It was created by Facebook, so the perfect use case is the Facebook site, Who would know? So basically what we have here is a big master page having multiple different nested components inside of another, highly interactive on many different levels, and highly isolated. Those are the ideal specifics for it, but not only. What we are interested in is low bandwidth, high latency networks. So, for example, mobile. If you are using Twitter on mobile, they use GraphQL for this exact reason. And when you have public API accessed by third-party consumers, why? Because you are not able to foresee every single need that those customers have for you. Instead of that, you can just expose, the part of the domain you are able to expose to them, and they are then responsible to, figure out and fetch the data they need. And this is a great tool to work with that, actually. So, in summary, sorry that I have to, speed up a little, because we are probably slightly out of time. But I'm sorry for a lack of examples, really. And I hope that this very short and speed up presentation gave up some useful predictions for you and reason why to use GraphQL and when not to use it. Because there are no silver bullets here. We are, I think, old enough to actually realize that. So, thanks.